So what we've been doing to this point is real introductory stuff, like how to display data, how to organize data. We have not done really any analysis. We've done a little bit in terms of correlation, but really we haven't done the stuff that statistics is really about, and that's analysis. And chapter 3 we start the process of figuring out what our data means, and that's really the basis for and the strongest use for statistics. So 3.1 is about what's called measures of central tendency. Okay, and that's what it really means is what's happening with the data in the middle of the data. And there's lots of different ways to look at it, and today we're going to look at a few different ways. These 4 ways specifically: the mean, the median, the mode, and the mid-range. These, yeah, you know some of these for sure. You've done some of these before. We're going to put it into more mathematical terms, in some respects, in terms of its symbolism. We're going to talk about how to find some of these things from a set of data. We're going to talk about how to find some of these things from a grouped data set. And so that will be a little bit different, and we'll look at it also when weights are involved. So that's what we're going to do today.
Is mid-range just a range?
No, it is not. Okay? So let's start with the mean. As you probably remember, the mean is the average of the data. Okay? In case you were not aware of what that means, sum of all the data values divided by the number of data values. Okay? Add them up, divide by the number of numbers. That's how you find the mean. Now technically, there are 2 types of means that you can find. Okay, you can find the sample mean, and you can find the population mean. And the difference is, you have to know through the data given to you whether or not all of the population, every single value in the population was used, or a portion of it. We've talked about sample versus population. Okay. And the process for finding the mean ends up being the same. The notation is a little bit different. Okay, but the process still remains the same. And oftentimes you just have to decide based on the information you're given, is this part of the whole or is this the whole thing here? Okay. So for the sampling, okay, this is some mathematical notation that I'm going to kind of talk you through. So the sample mean, the way that we indicate we're talking about the mean, is we have a capital X with this bar over it. This means sample mean. Bless you. Okay. Anybody know what this sigma? This is the capital letter sigma. It's a Greek letter. Sum of, right? So you're adding up all the x's. So in this case, this means add up all the data values. Lowercase n is just the number of data values that there are. So this is a mathematical way of expressing this here in red. Okay?
Sigma, can you
I'm sorry?
Can you just say like sigma is again?
Yeah, sigma is the sum of the values, adding up. So the sum of whatever all the x's are. Sigma means add them up. Okay? So again, x with the bar over is the mean, the sample mean. Sigma x, the sum of all the x values. Lowercase n, the number of values. Okay. Again, the idea is the same for the population mean. The notation is a little bit different. So here's the population mean. Okay. This is a lowercase Greek letter mu. Okay, those of you who are in mu alpha theta, that's a lowercase mu. Okay? And again, sigma x, you're still adding up all the values, and now it's an uppercase N. It's still the number of values. It just happens to be all of the values of that population. again, mechanically, what you do is not any different. Symbolically, it's a little bit different. Okay? The x bar for the sample mean, the lowercase mu for population mean, and then you have the lowercase n for the number of data values in the sample. Uppercase n is the total number of values in the population. Okay, again, symbolically, it's a little different. Mechanically, what you actually do is the same. Okay? Alright. The next one we're going to talk about is median. What's the median? Does anybody remember before I put it up there?
Middle. Not middle.
The middle, except what? You got to put them in order first. Okay, that's the key. Okay? So the median is the middle data value when the data is in ascending order, smallest to biggest. If it's not in ascending order, you have to put it in ascending order. One of the common mistakes that happens with the median is people just pick the middle number without paying attention of whether or not the numbers are in order. Okay, if they're not in order, you've got to put them in order first before you choose the middle number. There's one slight exception that we have to kind of pay attention to. There are times when there is no middle number. Maybe you're wondering, how is that possible? If there's an even number of numbers, right? The middle will actually be in between two numbers. So when you have an even number of data values, the median is the average of those two middle ones. Okay? So let me just make up a data set real quick to kind of show you what I mean. Okay? Obviously, real basic, there's only 4 values. The middle is here, right?
Yeah.
I've got 2 on the left of that red line, 2 on the right. The median would actually be a value that's not part of the data set, 2.5, because that's the average of 2 and 3. All right? If it had an odd number of values, okay, then 3, the median, would be part of the data set, because now I have 2 on either side. There's an actual middle number. Okay? You can think about it that way. So one of the things that I would do if I were you, if you're asked to find the median, after you make sure that your numbers are in order, determine if there are an even or odd number of data values. Because then you know, is my median going to be one of the values, or am I going to end up having to take an average? So it kind of helps to know going into the problem what you're dealing with. Are you dealing with a straight up number, or are you going to be dealing with the average of 2 numbers? Now, the other thing that can happen is that the 2 numbers are the same. So let's say I had a data set like that. The middle is still here. Well, it's pretty simple, right? It's got to be 2. You could go and like, all right, 2 plus 2 divided by 2. But it's the same number. The average of the same number is going to be the same number. Okay. So those are the 3 kind of examples I want you to kind of think about. Okay, any questions on median? All right, let's talk about mode. Anybody remember what mode is? Bridget? What do you mean the most? The number that appears the most. Look at that. She almost stole my line. It's pretty good. Okay, the data value that appears the most times. Statistical reference would be the data value with the highest frequency. Within the mode, there are lots of different cases and terminology that we use. Okay. If there is one number, one data value that appears the most times, we describe it as unimodal. So if there's only one mode, then it's unimodal. It's possible to have a tie, that there might be 2 data values that appear more than any of the other data values. Would you like to take a stab at what that's called?
Combined one.
bimodal. That is correct. Very good. 2 data values that appear the most, then it is bimodal. And then we stop naming them if there are 3 or more that are tied for the lead. What is it? Polymodal? No, that is not correct. But that's a good guess. That's actually a really good guess, but it's not. Anybody want to take another try? Or do you want to go back? You want to give it another try? Multimodal. Very good. Well done. I couldn't get the underline to match the color of the... I couldn't make it green. So it's purple. For those of you who are a little OCD like me, and that's bothering you, I'm sorry, it is still bothering me. And it doesn't matter at all. Like, that is completely inconsequential, but it still bothers me. Now, it is possible that there is no data value that appears more than another. Okay? And when that happens, they actually don't appear more than once. So, for example, if I had a bunch of data values that appeared twice and only one of them that was once, that's multimodal. Okay? But if there's no data value that ever appears more than one time, meaning the frequency of each data value is always equal to 1, then we say there is no mode. And I felt like I should have underlined that, but, it's not a vocabulary term. It's just, we already used it, so that's why I didn't underline. Yes? If they all appear twice, then it is multimodal. They're all the mode. So if they all appear twice, and when we get into further analysis, the mode does us no good at all. It's completely useless if that's the case. Right? If they all appear twice, it's multimodal, and using the mode to do any kind of analysis just really isn't helpful. Okay? The mid-range is the lowest value plus the highest value divided by 2. It's the average of the lowest and highest value. That's the mid-range. It's not the midpoint. Okay? It's not the median. But it's another central tendency measure. Lowest value plus the highest value divided by 2. All right, let's look at an example. So here's some data. It has no meaning. It's whatever. We're just going to work through the mechanics of how to do all of these things. So based off of this data, I want you to find the mean, the median, the mode, and the mid-range. Please show your work. Go. So here's what you should have done for the mean. When you added them up, did you get 136? There's 9 data points. You divide them out, 15.1. How many had that? Very good. So yeah, go 1 decimal place beyond what the data is. Okay? Median, do I have an odd or even number of data values? Odd. Okay, so that's good. Put them in order. Which one's in the middle? Okay, 7 is in the middle. That 4 on either side. Sophia was doing something that we used to teach when you were just learning this. In case you want to use this, you can. If you cross out 1 from each side until you get to the middle, how many remember doing that? You can do that. 7 is the one in the middle. Okay? Another way to do it, median 7. Mode, is there one that appears more than another? 3. What do we say about this? Unimodal. There is one mode. Mid-range is going to be, what do I do? 31. 1 plus 61 divided by 2. 31. How many had all 4 right?
I did.
Very good. All right, let's make it a little more complicated because that's too easy for you. I know you get scared when I say that. I like that. Funny. Okay. Yeah, you can go ahead and take a picture of that. So this is a group data set. Okay? And finding the mean from a group data set is a little more involved. When we're given a set of data represented this way, what's the problem? What's the issue? Do you have an idea?
There's a bunch of numbers.
Well, yes, there are a bunch of numbers. That is true. That by itself is not a problem. Yes.
It doesn't like start
Right. We don't know. We don't know the actual data values. All we know is one data value appears in this class. We just don't know what it is. Okay? It could be anywhere from 5.5 to 10.5. But it's in here. There's one of them. But we don't know what it is. So we have to assimilate somehow. Okay? Same thing down here. I know that there's two values in here. I don't know what the actual values are. So the idea that we could just take the values, add them up, divide by the number of numbers. I mean, there's 20 numbers. We know that. But we don't know what the actual data values are. So when you're presented with something like that, we have to use, anybody want to take a guess what we use? Who said it? I heard it. Anthony? What'd you say?
Calculation.
No, you just said it. Did you say it? Midpoint, that is correct. Hunter said it. We will find the midpoint of the classes, okay, and we're going to use those midpoints to basically estimate what the values would be. So, find the midpoint of all the classes. Go. And just as a little aside in preparation for getting your test back, when you make a frequency polygon, you must use the midpoints. So those of you who made a frequency polygon yesterday on your test, from the actual class widths, you did not get it right. For those of you who made a histogram for the frequency polygon, you also did not get it right. You need the midpoints to make a frequency polygon, and it's a polygon, which means it has to connect at the x-axis to make a polygon. Just a preview for your test. Alright, midpoints. You figured out that there's a pattern, right? Once you find the first couple, you don't actually have to do the calculations for the others. In case you didn't figure that out yet. What's the midpoint of this first class?
10.7.
8. Okay, 5.5 plus 10.5, that is 16 divided by 2. That is 8. What about the second one? 13. Okay. So what's the next one going to be without doing a calculation? 18. It goes up by 5. Okay, there are your midpoints. Okay. So in order to find the mean from a group data set, what we do is we make this assumption because it's an estimate. We assume, for the sake of our calculations, that these are the data values. Okay? And that 8 appears once, 13 appears twice, 18 appears 3 times. Okay? So instead of going, for example, 8 plus 13 plus 13 plus 18 plus 18 plus 18 plus 23 plus 23 plus 23 plus 23 plus 23 until it's 5 times. I don't remember how many I said. Okay? Instead of doing that, there's another way that we can come up with those values. What do you think we should do? Yep. So our next column is multiplying the frequency by the midpoints, and then I'm going to take these values and do what with them? After I have them, what do you think? Well, what do I got to do with them? Add them up, thank you. Okay, so go ahead and find this column, the frequency times the midpoint, and then we're going to add them up, because that's going to give me the sum, the sigma. The sigma part over here is what we need. So this column, when I add them up, is the same as when we found the mean the first time. When you added up all the data values, it's the same idea. Instead of adding each 13 individually, I multiply by the number of 13s that there are, and then I'm going to add all of these up. What I end up with is this. So this is the sum of all these values. It would be like if I had all of these numbers written out. 1 8, 2 13s, 3 18s, 5 23s, 4 28s, 3 33s, and 2 38s. If I had them all listed out and then I added them all up, a shortcut around that is to multiply the number of times that they show up and then add them up. So in order to find the mean, what do you think I'm going to do next? Divide what? What two numbers will I divide? 490 divided by 20. Okay. So here's what this formula looks like from group data. Let's just break this down, okay? Of course, our mean, x with the bar on it. The sum of the frequency times the midpoint. That's what this is. All this means is add up all the frequency times the midpoint values, and that's this column over here, divided by the number of numbers.
So,
What's it S times X?
So this is the frequency times the midpoint. This x sub m means the midpoint. So this column is this. The sum of that column we already actually have over here. So all of this is the sum of the frequency times the midpoint. That's what this means. F for frequency, x sub m is midpoint. So we add those all up, divide by the number of numbers. In this case, it's 490 divided by 20, which is 24.5. And it's an estimation, okay? Because we don't actually know what the data values are, we're coming up with an approximation, an estimation of what it might be. Okay, we've got one more thing that we need to talk about. Question, yeah.
never mind.
Okay, yes.
What does the X with the bar over mean?
This x,
Yeah.
mean. Okay. The last thing we need to talk about is, I gotta talk about one more thing as we're talking about group data set. The mode for group data is called a modal class. So when I have group data, meaning again, I don't know the actual data values, you go by the highest frequency. So for example, if I had this, instead of having a mode, because I don't know what the actual numbers are, I know that the mode appears, the data values in this class appear the most. So instead of saying, like we did before, 3 was the mode, because we don't know the actual data values, we choose the class that has the highest frequency. And in this case, the class with the highest frequency is right here, because 5 is bigger than the rest of them. So, even though we don't call it mode, we call the class 20.5 to 25.5 the modal class, because it's the one with the highest frequency. Again, we don't know the actual data value, so that's why we can't pick one specific data value. Okay? So that's the modal class when you're given group data. Otherwise, when you know the actual data, you can find the actual mode. Alright, one more thing to cover. Last thing to cover is the weighted mean. Okay? So, in our previous examples, each data value had the same weight. It was each worth 1 or whatever. Okay? You're going to be presented with data where it doesn't work out like that. And a perfect example of that is your grade in this class. That's called the weighted mean. Your grade is calculated on a weighted scale, right? We take the average of your homework grades, but that only gets so much weight. We take the average of your quiz grades. That's only so much weight. We take the average of your test grades, but that is also only so much weight to come up with the whole, right? That's an example of weighted mean, and we're going to go through an example like that right now. So the data values don't have the same weight. Okay, and that's what this says. That is in fact supposed to say data sets. Dates set. Now it says data sets. Alright, let's look at an example. My example is grades in my class. Okay? Let's say this was one of you. It might be, I don't know if it is. I made the numbers up. I did not look at your scores to see. Let's get back into this. So real quick, all this means is that the average of the homework grade, which is 95%, is only worth 15%. So it does not have equal weight as the quiz grade or the test grade. So those of you who are lamenting about your grade, for example, know that your big moves are going to come from improving your test grade, because that's worth 60% of your overall grade. So in order to do the calculation here, it's similar to the group data set, that where we multiplied by the frequency. Okay, in this case, instead of multiplying by the frequency, we multiply by the weight. And so I'm going to have to convert all this into decimals. So 95% of the grade is only actually worth 15% of the overall grade. 87% quiz grade is only worth 25% of the overall. And the test grade, 89%, is worth 60%. Now, this, of course, has to add up to 100% of my grade. So in the beginning of the year, before we have a test, when you guys had a quiz grade, all of a sudden your grade made this big jump, it's because there was only 40% of your grade counted. And then all of a sudden you got a test grade in there, and everything changed. Okay? So in order to do the weighted mean, it has to look like this. Okay? Now, all this is saying, take this 95% times 15%, add to that the 87% times the 25%, basically counting for the weight of these grades, and then 89% times 60%. Now, I wrote divided by 100%, and of course 100% equals what number?
The total grade.
1. It's the same as 1. So dividing by 1 doesn't actually do anything for us. But I wanted to put it there because there are going to be some problems that you work on where the weight is going to be different. It's not going to be 100%. It actually won't be percents at all. It'll be more about frequency. So just keep in mind that you will have to do some division of the total weighting. Just know that it's not always going to be 100%. If it is, there's really no division involved. So go ahead and calculate this person's grade. And this is how your grade actually works. So if you want to see your homework grade and quiz grade and test grade and see if Canvas is calculating it correctly, you can use this. Use this same idea to calculate your semester grade too. Because first quarter grade is 40%, second quarter grade is 40%, midterm is 20%. So you can use this same sort of idea to calculate your semester grades as well. And I know that happens. So
We get out of your midterm if we have a 93 or above in your class as seniors. Or
what grade does this person have? 6. That is incorrect. 89.4%. Now, make sure that you convert it back to percent. Okay? Again,